few examples on integration by parts. Okay, so as soon as you're comfortable, we'll move on to the next technique. So let's start with the integral of arcsine of x. Then in the second one, the integral of ln x. And third one, so let's take one from the worksheet, the one that you asked. I'll do 11, you said?
Yeah, I said 11 and 19.
Let's try 11. It's x arcsecant. Okay, so here are three. All right, so we'll do it by parts. What's going to be u? So u
Arcsine.
Very good, because Lie, so inverse trig, right, is priority. So arcsine of x, and dv, of course, whatever's left is just dx. And then, so du, the derivative of arcsine is 1 over the square root of 1 minus x2 dx. And if dv is dx, then v is just x. Okay, let's apply the integration by parts. So uv x arcsine x minus the integral of v times du, which is x over the square root of 1 minus x2 dx. Okay, so far? So now I just have this integral to evaluate. So I could use a substitution here. I'm going to call 1 minus x2 as u, okay? Therefore, du is negative 2x dx. I'm just going to do it here because I want to leave some space. Okay, so du is negative 2x dx, and therefore x dx, which is what I have here, is negative du over 2. Okay, so what do we have? X arcsine of x minus, so the integral of, so x dx, which is d over 2, so 1 over the square root of u times negative du over 2. Hope you can see, and it's not too small. So equals x arcsine of x plus, right, minus is plus 1/2. And the antiderivative of u to the negative 1/2 is u to the 1/2 over 1/2. Okay, so I get x arcsine x plus square root of u, which is 1 minus x2 plus c. Let's see if out of the outside the bracket, the square roots. Sorry, it's a bit small. Let's just run out of space. Can you still see, I hope?
Yeah, we can see it.
Okay, good. Okay, the second one.
Oh, sir?
Yeah.
Could you repeat the last line again, please? What you did at the last line?
The whole line.
Yeah, to get from the integral
Okay,
to
okay,
the, yeah.
So this is u power negative half. See?
Yeah.
This here. U power negative half. So you add 1 to the power rule. Negative half plus 1 is 1/2. Here it is. Divided by n plus 1, which is half. So u power n plus 1 over n plus 1. Okay? Then here the minus and the minus became a plus. I don't know if you can see my. Okay? And that's it. That's it. U power negative half plus 1 over negative half plus 1 on the bottom.
Okay. All right.
And
Thank
then
you.
the next step, I just replace the u back by 1 minus x2 and I'm done. Okay, next one. So same idea here. By parts, u is ln x, right? Don't forget the priorities. And dv is dx. So v is just x, and du, derivative of ln x, is 1 over x dx.
So there's someone in the waiting room.
Excuse me?
There's someone waiting for you in the waiting room.
Okay, thank you. Okay, let's go. So it's equal to uv, so x ln x, minus the integral of v du, which is x times 1 over x dx. Okay, so it's x ln x minus, and x over x is just 1. So the antiderivative of 1 dx is just x. That's it. That's an easy one. Third one. So u is the arcsecant, and dv is x dx. V is x squared over 2, and arcsecant, the derivative of arcsecant, is, if you remember, it's 1 over x root of x squared minus 1 dx. Okay, equals uv, so x2 over 2 arcsecant x minus the integral of v du, so minus 1/2 integral x2 over this, so it's just x over x root, sorry, no x on the bottom. Okay, I just crossed out the x2 over the x. Disappeared. X squared minus 1 dx. Are you okay with this? Okay, and then I'm gonna do substitution here. U is equal to,
So you multiplied both and then you canceled one x
yeah,
with the other. Okay.
yeah, exactly. Okay, so U equals x2 minus 1. And so du is 2x dx, which means that x dx again is du over 2. All right, I'm just gonna take some space from here. Okay, so it's equal still x2 over 2 arc secant x minus 1/2 times, so x dx, so integral of 1 over, again, root u times dx, which is, x dx, which is d over 2. So just like we had before over there, okay, it's the same integral, pretty much. So x2 over 2 arc secant x, so minus 1/4. And the integral of u to the negative 1/2 is u power 1/2 over 1/2 plus c. And then I just replace, I hope I could fit it. Algebra just below. Minus, so u is x2 minus 1, so power 1/2, so square root of x2 minus 1 over 2 plus, this is what I get.
Sorry, sir, but could you explain again how you did x times 1 over x dx becomes just negative x plus c in the lambda one?
In the what? The lambda?
In the middle one.
Oh, here?
Third to fourth line.
Okay, here?
Yeah.
Okay, so this x over x cancels, right?
Yeah. Oh, and then you just,
The integral of 1 is just x.
okay, yeah.
Good? Okay.
Yeah.
So here's a classic, e to the x times sine x dx. Okay, so this one we'll do together. But you could help me out. So what should I do? What should I put as a u? What's u?
Sine x.
Very good. And so du I want to find, and then of course dv is whatever's left, which is e to the x dx. And I want to find v. Okay, so the derivative of sine is cos. And the antiderivative of e to the x dx is just e to the x. Okay, so I'm ready to do my integration by parts. So equals uv, so e to the x sine x minus the integral of v du, which is e to the x cos x dx. How do we do so far? No questions? Okay, this is straightforward, just like we did until now. And we have to evaluate this integral now. And we're going to do it by parts again. Okay, so let's go. U equals, this time I'm going to take cos x. I'm going to find du, and then dv again is e to the x dx. And I'm going to find v. Okay, so what's du?
Sir?
Yeah.
We're doing by parts again,
Yeah.
like the second time.
Yeah, for this interval. So this is done. Now we have a new problem is to evaluate this interval. Okay, or find the antiderivative here. So cosine, what's the derivative of cosine?
Minus sine.
Very nice. So minus sine x dx. And e to the x dx, the antiderivative is e to the x. Let's go. So it's e to the x sine x, which is this term, which is still here, minus, and now I'm going to do by parts for this one. uv, which is e to the x times times cos x. uv. Minus the integral of v du, which is e to the x times negative sine x dx. Get minus, so it becomes a plus. You guys okay with this? So if I simplify, I get e to the x sine x minus e to the x cos x minus this integral. And I get back to what I started with. So it looks like I'm going to keep going in circles. If I do by parts again, then I'm going to have to do this whole process and go in circles and circles. Okay, so what do? How do I solve this?
I isolated like e and the integral of ex sine x dx.
Okay, very good. Okay, so what I have is this integral. So the integral of e to the x sine x dx is equal to e to the x sine x minus e to the x cos x and minus the integral of e to the x sine x dx. That's what I have. Okay, so like she said, these two are the same. So I could send this whole term on the left side, and it will become 2 times this integral. Is equal to this. Okay, and then I just divide by 2 and I'm done. So it's 1/2. Okay, 1/2 times this. So I could extract e to the x also. So e to the x over 2 times sine x minus cos x plus c. And I just found my antiderivative. Okay, so this is one also from your worksheet. E to the power of the square root of x dx. Okay, so I'll do this one. So the first thing you do, this is a trick. When you have a square root of x, it's very useful to do a substitution first with this square root. Okay, you'll see why. So I'm going to call it t is equal to root x. Okay, I'm not going to use u because I'm going to save the u for the integration by parts that's going to come right after. Okay, so t is equal to square root of x. Therefore, dt is what? The derivative of square root of x is 1 over 2 root x dx. Okay, and so dx is 2 root x, 2 root x times dt, but root x is t. So dx is 2t dt.
Oh wait, sir.
Yeah.
Could you explain why square root x becomes 1/2 square root x?
So the derivative, why is this derivative here? This?
Yeah.
Okay. This is the calculus 1 question. Okay, so square root of x prime is like x to the 1/2 prime, and then you do the power rule. So it's 1/2 times x to the 1/2 minus 1, which is -1/2. And that's 1/2 x to the half.
All right, thank you. I forgot.
No problem. It's okay. Okay. So this was a tricky part here. First, realizing, but I told you that when you have a square root, chances are that's what you're going to take as a substitution. Why? Because when you derive it, the square root reappears. And therefore, you could re-replace it by t. Okay? So I could express the x in terms of t's. Okay? So again, I isolated the x is 2 root x times dt, but root x is t, so it's 2t dt. And now I'm going to rewrite this integral. The integral of e power root x, which is t, times dx, which is 2t dt. Okay? Which I could do by parts now. Okay? So I'll just pull out the 2 in front. E to the t, t e to the t. And let's do by parts right here. So u is equal to t. I'll find u, and then dv is e to the t dt, and I'll find v. Okay, u equals t, so du equals dt, and dv is e to the t dt, so v equals e to the t. Okay, let's go. Let's finish it up. So it's 2 times uv minus the integral of v du. Which is 2 times t e to the t minus the integral of e to the t, which is just e to the t plus c. And then the last thing to do is what? I replace the t back by its value of square root of x. So 2, I'm going to pull out an e to the t, so power times e to the root x times t minus 1 plus. And that's my answer. So the integral of secant squared of the square root of x. Yes. Okay, so very similar to what we just did, so you should follow the same steps. Okay, so my first step is I'm going to substitute root x, I'm going to call it t, so t is root x, which means that dt, just like before, is 1/2 root x dx, and therefore dx is 2 root x dt, so 2t dt. Okay, just like we did 2 minutes ago. let's rewrite integral of secant squared t times dx, which is 2t dt. And that is 2 integral of t secant squared t dt. And now we're ready to do it by parts. Okay, so u, what do I take as u?
Took T.
E, very nice. So du, of course, will be dt, and then dv is secant squared t dt. So v is tangent, right? The antiderivative of secant squared is tangent. Tangent. So uv, so t tangent t minus the integral of v du, which is tangent t dt. Okay, so this one I think we did in the substitution worksheet. Tangent is sine over cos. Okay, and if you remember, we called u equals cos t, du is negative sine t dt. Okay, so sine t dt will be negative t.
Sure.
Yeah.
What happened to the 2 from the other side?
I forgot it.
Okay.
Thank you. Okay, so there's a 2 here. Thank you. You're right. So all this times 2. Thank you very much. Okay, so 2 times t tan t minus, and this becomes 1 integral of 1 over u, right? 1 over cos is 1 over u, times sine t dt, which is negative t. Okay, so it's 2 times tan t times tan t plus, right, minus minus plus, and the antiderivative of 1 over u is ln of u. Okay, so it's 2 t times tan t plus 2 ln absolute value of u, which is cos t, plus c. And then I replace the t by the square root of x and I'm done. There you go.